Hello everyone, I am Prashant Dandi. Welcome to my channel. Today we'll solve the problems of derivatives. Some of the basic things that will be needed for solving the problems of the derivative we'll solve here. So first of all, we should know the some basic formulas. We know the formula of x to the power n. What is the derivative of cos x? What is the derivative of sin x? That we need to know. And using that tools, we have to find the derivative of some of the problems. So I will solve some problems using that one, and there are some types. Okay, so first of all, simple type, we'll solve some simple type problems. So suppose there is a question here. I'm just writing the question here. So simple one is x plus sin x divided by 1 plus cos x, like this. Okay, so we'll start from simple type problem, then we raise your level. So first one is this one. So this one is x plus sin x and 1 plus cos x. So we have to find the derivative of this one, ddx of this one. So this is a very basic problem. Now how to solve this one? So first of all, you can see this is the number x plus, here is its x plus sin x and 1 plus cos x. So first we have to let this one as u and this one as v. So this my first function, the numerator as u and the denominator is here v. Now there is a formula for division. So what is the formula? You have to know the formula. So ddx of u by v. So what is the formula? V du dx minus u dv dx by v square. Okay, so this is the formula that we need to remember for solving that type of problem. So here you can see it is x plus sin x by 1 plus cos x. Now how to solve this? So here you can see this is the u. So what will be my answer here? First of all, what is the constant here? First v will be constant. That means here 1 plus cos x, that will be the constant one. Then you have to differentiate that one, ddx of u. Now here what is u here? Here the u is x plus sin x, that is my u here. Then minus u. Now what is the u here? Same thing, x plus sin x, x plus sin x, then ddx of v. What is v here? We can see here v is 1 plus cos x. So this is the v. And now the denominator. What is the denominator here? The denominator is v square. So here you can see the v is 1 plus cos x. So that means that will be 1 plus cos x whole square. So like that, only this is a simple problem. First we have to check where is e, where is v. So you can see the numerator is here u and denominator is v. Then you have to apply the formula of u by v. So first use that one. Next we have to find the derivative of that. Now next one is, what is the number is there? 1 plus cos x. There is 1 plus cos x. Now differentiate x. Now what is the differentiation of x? We know the differentiation of x is here 1. So that will be 1 plus the derivative of sin x is here cos x. So you know the derivative of sin x is here cos x, minus then again x plus sin x. And here you can see derivative of 1 will be 0 and cos x derivative will be minus sin x, like this. And here it will be divided by 1 plus cos x whole square, like this. So that will be the answer. Then you have to simplify this one, and from this you will get the result. So how to simplify? So here you can see the numerator. What is the numerator here? The numerator is 1 plus cos x whole square minus, now here look at here, it is x plus sin x into minus sin x. So minus minus will be plus. So that will be plus sin x into x plus, here you can see sin x into, we can see x plus sin x. Okay, so that will be x plus sin x. And the denominator will be, we can see 1 plus cos x whole square. So here the denominator will be 1 plus cos x whole square. That will be that 1 plus cos x whole square. Next, like this. Now you can just use the formula a plus b whole square plus this one. You have to multiply this one and simplify, that will get the result. So this is the way. So this is the basic one, first one. So here we have used the formula of division. So first one. Now question number 2. Next is question number 2. Now how to solve this one? Question number 2. This is always basic one. So question number 2. ddx of x plus tan x into something like log x. Suppose this is given. Okay, so x plus tan x into log x. Now how to solve this one? Again, this is a basic part. So here we can first, here this is the product rule you have to use. Look, this is the first function, this is the first one, and this is the second one. So this is the first function, this is called u, we can call it v. So here you can see this is a product form. So whenever there is a product form, what is the formula? ddx of u into v. What is the formula? V into du dx plus u into dv dx. So that will be the formula. Okay, now here we can see what is u, what is v. Now here my function u is x plus tan x, and what is the v here? The v here log x. So here we can write like this: log x into derivative of ddx of x plus tan x and plus u. U is here x plus tan x into ddx of log x, like this. Now we can find the derivative here, dd log x into the derivative, that means ddx of x will be what? 1 plus, and ddx of tan x will be sec square x, okay, plus x plus tan x into, now what is the derivative of log x? That will be 1 by x. Now again you have to multiply, and then we'll get the simplest form of that one. So this is the way, those are the basic forms. So whenever there is a multiplication form, we have to use u into v formula, and whenever there is a division form, we have to use u by v formula. So those are the formulas that will be needed here to solve the problem. Now go to some important problem. Now question number 3. Okay, now step by step we'll raise our level. So question number 3 here, look at the question number 3. So what is given here? It is given y equals to sine x by 2 plus cos x by 2 whole square. Okay, so it is given sine x by 2 plus cos x by 2 whole square. We have to find dy dx. We have to find dy dx at the point x equals to pi by 6, at x equals to pi by 6. Now how to solve this one? Okay, so this is also easy. First of all, what we need to do is that first we have to simplify the term here. So it is given sine x by 2 plus cos x by 2 whole square. Now you can see this is a plus b whole square form. So here first we have to write what is a plus b whole square form. So this is a square, the formula is what? A square plus b square plus 2ab. So this is the form. So this is the first one. So a plus b whole square, first simplify this one. So a square plus b square plus 2ab. Now this one you can see this is sine square and this is cos square, and sine square plus cos square is what? 1, and 2 sine x by 2 cos x by 2. This is the trigonometry formula. This is the formula of sine x. This is the trigonometrical formula. Sine x is equals to 2 sine x by 2 cos x by 2. So here it will be y equals to 1 by 1 plus sine x. Now what we need to find is the dy dx. So here that means we have to differentiate with respect to x. So I am differentiating both sides with respect to x. So d dx of this one 1 plus sine x. Now from here we can see there is a 1. So what is the derivative of 1? The derivative of 1 is 0, and derivative of sine will be cos x. So here you can see derivative of 1 is 0 and derivative of sine is cos x. Now which point at x equals to pi by 6? That means whatever point is given, after doing the derivative we have to put the value here. So here you can see, so we have to put x equals to what? X equals to pi by 6. That means cos 30 degree. Now what is the value of cos 30 degree? That is root 3 by 2. So that will be the answer like this. Okay, so whatever value is given, first you have to simplify that one. If it is possible to simplify, so you have to simplify that one. After doing the then you have to do the derivative of that one, and whatever point is given you have to put it here. Okay, so this is the question number 3. Now move to question number 4. So next one is question number 4, this one. Okay, so question number 4. So what is the question here given? So this is given here, root over of 1 minus sine 2x. Okay, 1 minus sine 2x by 1 plus sine 2x. This is given y. This is the y here. Okay, we have to prove that, we have to show that the dy dx, okay, dy dx plus sec square pi by 4 minus x, that will be 0. Okay, so this is given, root over of 1 minus sine 2x by 1 plus sine 2x equals to y. Now we have to show dy dx plus sec square pi by 4 minus x, that will be 0. Now how to solve this one? So first, question number 4. So here again we have to simplify. First, if it possible, we have to simplify the result. Then from that we have to find the derivative. So here root over of only trigonometry, there will be only trigonometry. So you can see there is a 1. So whenever there is a 1, we know there is a formula, cos square x plus sine square x minus, then it is sine 2x. So what is sine 2x? Sine 2x is 2 sine x and cos x. So you have to remember some formulas. Okay, some basic formulas of trigonometry that will be needed. So what is the formula? I'm just writing the formula. Just remember those formulas. So first formula is sine 2x. This is a very important one. 2 sine x and cos x. 2 sine x cos x. This is sine 2x. This is very important one. Next important one is 1 plus cos 2x. Okay, again this is very important. This will be 2 cos square x, and next one is 1 minus cos 2x, that is 2 sine square x. So whenever there is a plus, that will be cos square, and whenever there is a minus, we can say this is sine square. So we have to remember these 3 formulas. That is very important for this chapter, that will be needed. So here you can see cos sine 2x is 2 sine x cos x, and this is. Now next is that again 1 can be written as cos square x plus sine square x, and the denominator, and again plus sine 2x can be written as 2 sine x cos x, like this. So here the numerator, in the numerator we can see this is a formula, algebra. So this is a square. Look at here, this is a square, this is b square, and this is 2ab, like this. So here we can write like this, cos x plus sine x, this whole square, and here also cos x minus sine x, that whole square. Since whole square and this is square root, so we can write like this, cos x minus sine x, sorry, cos x plus sine x, and here it will be cos x minus sine x. So this is the y. So y is here cos x plus sine x and divided by cos x minus sine x. Now look at what we need to prove there, sec square pi by 4 minus x. That means there will be lot more simplification we can do here. So here cos x plus sine x. So what is the next simplification we'll do here is, we'll divide the numerator and the denominator by cos x. Okay, so what will happen if I divide it? So here y equals to, I am dividing the numerator by cos x, so that is cos x plus sine x divided by cos x, this one. Yes, and next one is, there will be cos x minus sine x divided by again cos x. Okay, so I am dividing the numerator and denominator by this one. If I divide this one, okay, if I divide this one, okay, any problem? Yes, there is a wrong, that will be minus. Look, that will be minus, because a square plus b square minus 2ab, that will be minus, and that will be plus. The denominator here, it will be plus. Here also it will be minus, and here it will be plus, like this. So there will be a change, slight change will be there. So here first numerator there will be minus, and the denominator there will be plus. Only that will be the change, because we can see here this is the formula: a square plus b square minus 2ab, the numerator, and the denominator it is a square plus b square plus 2ab. Okay, now if I divide both by cos x, what will happen? Cos x by cos x, that will be 1, minus sin x by cos x, that will be tan x, like this. And in the denominator, cos x by cos x will be 1, plus sin x by cos x, that will be tan x. So that is the y here. Now y equals to, look at here, 1. So 1 can be written as tan 45 degree, that is tan pi by 4, minus tan x divided by 1 plus, now look, nothing is there, that means we can call it 1 is there. Okay, if there is nothing, you can say 1 into tan x. So from here 1 can be written as tan pi by 4 into tan x. Now look at it properly. This is the formula. This is the formula of trigonometry again. What is the formula here? Tan a minus tan b by 1 plus tan a tan b. So what is the formula? Tan pi by 4 minus x. So you can see y is here what? Tan pi by 4 minus x. Now this is the simplest form. So here we are getting y equals to tan pi by 4 minus x. So it is coming y equals to tan pi by 4 minus x. Now what we need to find here? Derivative dy dx. That means we have to differentiate both sides with respect to dx. So I am differentiating both sides with respect to x. So that will be like this. Now look, there is a tan. Now what is the differentiation of tan? Differentiation of tan will be sec square pi by 4 minus x into, now this is the chain rule. Chain rule means first you have to find the derivative of that one. Now next inside of this one. So what is the derivative of this one? Derivative of pi by 4 is 0 and derivative of x is 1. So that is 0 minus 1. So from here we can write like this: dy dx, that will be minus sec square pi by 4 minus x. Now if it comes here, that side on the LHS, that will become dy dx plus sec square pi by 4 minus x, that will equals to 0. Okay, so that will be the proof. We can see this proved the property. Okay, so this proved the question. So here, from here, this one done. Okay, so this is the way. So first what we need to do is that first simplify this one. After simplification, you have to find the derivative of that one using chain rule. Now I will discuss what is chain rule here, how to do this type of derivative. Suppose there is a function sine log x square, like this. How to find the derivative of this one? To find the derivative of this type of function, what we need to do is that we have to use the chain rule. Now what is the chain rule here? Chain rule means first we have to differentiate the outside part, then we have to go one by one, like this. Now look, how many functions are there. First we can see there is a function sine. Okay, so we can take this as x, whole as a x. So this is sine here. Now what is the derivative of sine? We know derivative of sine is cos. Okay, and write whatever is there, log x square. Done. Now into, so sine is done, so completed. Now go inside. Now what is the next term here? Log. So what is the derivative of log? Derivative of log is 1 by x. So inside log there is x square, so you can write 1 by x square into, now log done. Now go inside again, x square. Now what is the derivative of x square? That is 2x. So again cancel this one, that will be cancelled out. So that will be 2 by x cos log x square, like this. Okay, this is the way to do chain rule. So in chain rule, first we have to go from outside and then one by one. How many functions? Many functions will be there. You have to differentiate one by one, like this. Okay. Now next one is question number 5. we'll do question number 5. So what is the question is given here? So question is given. Now here we have to use the chain rule. Okay, so first question here, cos tan root x plus 1. So this is given, you have to differentiate this one. Okay, so again chain rule. Here it is a chain rule problem. Now again same thing, from the outside you have to go inside. Now first you can see here, this is the, what is the first function is there? Cos. Then here it is tan, then here it is root. So first it is cos here. So what is the derivative of cos? We know the derivative of cos is minus sine. So just write minus sign, and whatever be inside, just you have to write it down. Tan root x plus 1. Then into. Now cos completed. Now what is the next one? Next function is here tan. Now what is the derivative of tan? Derivative of tan is sec square, and whatever be inside you have to write it down, x root x plus 1 into. Now tan again done. Now again is, now next is root. Now we need to know what is the derivative of root x. Okay, so we need to know what is the derivative of root, any root function. That means root x, what is the derivative? So we know derivative of root x. Root x means x to the power half. So what is the derivative? X to the n formula, half x to the power half minus 1. So this is the form. So here you can see half x to the power minus half. So that will be 1 by 2 root x. So this is the derivative of root x. So from here we can see, so derivative of root x is what? 1 by 2 root x. So there is a root. So what will be the derivative of this one? The derivative of this one will be 1 by 2 root x plus 1. Done. Into, now next one, what is there? X plus 1. We have to find the derivative of x plus 1. So what is the derivative of x? That is 1, and derivative of 1 is here 0, like this. So the answer will be here minus 1 by 2 root x plus 1 into, again you can see this is sine tan root x plus 1 into sec square, that will be root x plus 1, like this. Like this, that will be the derivative of this one. Okay, so here you have used the chain rule. Again next one, question number 6. First pause the video and you can try this one, then watch this one. Okay, so question number 6. So it is given like this, sine ddx of sine cos x square, like this. Okay, so how to find the derivative of this one? Again the same thing, chain rule. So what is the chain rule here? First, what is here? Sine. So derivative of sine is here cos. So cos, and whatever be inside you have to write it down. The inside there is cos x square into, so sine cancel. Now here it is cos. Now what is the derivative of cos? That is minus sine. Now whatever be the inside you have to write it down. Again sine x square will be there. So cos cancel out. Now next one is x square. Now what is the derivative of x square? That is 2x. So the answer will be minus 2x cos x square into sine x square. So like this. Okay, this is the way to use the substitution to solve this type of this is the way to solve this by using chain rule. Okay, now next one we'll do by using proper substitution. Okay, so this is the basic type, chain rule and u by v and uv formula. Now next type 2, this is the type 1 where this is the basic problem. Now next is type 2. Type 2, it will be substitution. So using proper substitution we'll solve some problems. Okay, so first one, so for substitution you have to remember few things. Okay, what is the first thing is there? Suppose there is any 1 plus x square, like this term is there. So here whenever this term is there, we have to take x as tan theta or cot theta. Depending on that particular sum, we have to choose that one, tan or cot. Okay, now next, if there is 1 minus x square. Here we have to take x as sine theta or cos theta. Okay, because we know now 1 minus sine square theta is cos square theta, or 1 minus cos square theta is sine square theta. So depending on that, we'll take sine or cos. Number 3, again, if it is x square minus 1, we can take x as sec theta or cosec theta, because we know sec square theta minus 1 is cosec square theta, and cosec square theta minus 1 will be sec theta. This is one. And next one we can, so there is something in 1 minus x, 1 plus x. Whenever this root over of this type of thing will come, okay, root over 1 minus x and root over 1 plus x, you have to take x equals to like this, cos 2 theta. Okay, cos 2 theta, and use some formulas. Okay, so remember this type of substitution. Whenever this type of function will come, we'll take this type of substitution. Okay, so whenever there is 1 plus x square, the substitution will be tan theta or cot theta. Whenever 1 minus x square, we have to take sine or cos. X square minus 1, then you have to take sec or cosec, or number 4, this one. Okay, so using that, we will solve some problems. So first one is this one. Now number 1, under substitution. So what is given here? First it is given, find the derivative of this one, d dx of tan inverse x by root over of a square minus x square, like this. Okay, now how to solve this one? So first one is that for differentiating, first we have to substitute this one, simplify this one. After this we'll differentiate this one. Okay, so look here, this is a square minus x square, like this. 1 minus x square, like this type of thing is there, 1 minus x square. Now if it is a square minus x square, okay, instead of 1 there is a or something, any other constant. So what we need to do is, here we have to take x equals to a sine theta. Okay, you can see here, if it is 1 minus x square, we have taken x equals to sine theta. Now if it is a square minus x square, we have to take x equals to a sine theta, like this. Then now we can see here what will happen here, tan inverse x by root over of, this is a square minus x square. Now we have to substitute the value here. Okay, now substitute the value here, that will become tan inverse, it will be a sine theta divided by root over of a square minus, that will be a sine theta whole square, like this. It will look like this. So again it will look like tan inverse, it will be tan inverse a sine theta. Now from here we can take, what we can take, a square. We can take a square from here, it will be 1 minus sine square theta, like this. Okay, so we are just simplifying that one. Now we can see a square minus 1 minus sine square theta is there, and we know 1 minus sine square theta is what, cos square theta. So that will be tan inverse, it will be a sine theta divided by root over of a square cos square theta. Okay, now tan inverse, if I remove the root, square root, that will be a sine theta by a cos theta. Okay, now a and a will be cancelled out, so sine theta by cos theta, that will be tan theta. So that will be tan theta, and it will be theta only. Okay, so this will be a theta. So we know what is theta. Now from here we have to find the value of theta also. So here we have taken x equals to a sine theta. So we have taken like this, we have taken x equals to a sine theta. So what will be my theta here? So first it will be x by a equals to sine theta. So from here what will be the theta? Theta will be sine inverse x by a, like this. So from here we can write y equals to, look what y is here, theta. So that will be sine inverse x by a, like this. Now we have to find the derivative of this one, that means dy by dx. Now sine inverse, so sine inverse x, what is the formula? 1 by root over 1 minus x square. Okay, so here 1 by What is the formula? Root over derivative of sine inverse x is 1 by 1 minus root over 1 minus x square. That means this one square into, this is a chain rule. So second one, what is the term here? X by a. Now we know derivative of x is 1, so this is 1 by a. Now again simplify this one. If I simplify this one, that will come like this. That will be a by root over of a square minus x square into 1 by a, and a cancel out, so that will be 1 by root over of a square minus x square, like this. So dy dx will be like this. Okay, 1 by root over of a square minus x square. So this is the way. So this type of case you have to use the substitution. Okay, now next one is that, next number 2. Now question number 2, tan inverse root under of 1 plus x minus root under of 1 minus x divided by root under of 1 plus x plus root under of 1 minus x. Now how to solve this one? For solving this one, again you can say root under of 1 plus x minus root under of 1 minus x divided by root under of 1 plus x plus root under of 1 minus x. Now you can see there is 1 plus x, 1 minus x, again 1 plus x, 1 minus x. If this type of thing will come now, whenever this type of thing will take x equals to cos theta. Okay, x equals to cos 2 theta. Okay, so I am taking x equals to cos 2. Why x equals to cos 2 theta? Because whenever there is 1 plus x, that will be 1 plus cos 2 theta. Okay, now 1 plus cos 2 theta, what is the formula? 2 cos square theta. Done. And whenever 1 minus x is there, that will be 1 minus cos 2 theta. So that will be 2 sine square theta. Done. That's why you have taken x equals to cos 2 theta. Now we have to put the values here. So that will become what? That will become tan inverse root under of, now what is given here? 1 plus x. Now look at here, 1 plus x, what is the value? 2 cos square theta. So that will be 2 cos square theta. Done. Now here it is minus root over of, again that is 2 sine square theta. Same thing in the denominator also, that will be root under of 2 cos square theta plus root under of 2 sine square theta. 2 sine square theta. Now if I remove the root, that will be tan inverse of, now square root of 2, that will be root 2 and cos theta plus minus, that will be root 2 sine theta, like this. And in the denominator also, that will be root 2 cos theta plus root 2 sine theta. Done. Now from the numerator we can take root 2. So here we can take tan inverse of, if I take root 2 from here, that will be cos theta, now minus sine theta divided by root 2 into cos theta plus sine theta. Done. Now root 2 cancel out. Now look at here, there is a tan inverse. That means somehow we have to make it to tan. So how to make it tan? We just have done this one, this type of problem. So cos theta minus sine theta, and the denominator is cos theta plus sine theta. What we need to do is that we have to divide it, the numerator and the denominator both by cos. If I divide the numerator by cos and the denominator by cos, what will happen? Look, if I divide the numerator, cos theta by cos, that will be 1. Sine theta by cos, that will be tan theta. And here also, if I divide cos theta by cos theta, that will be 1. Sine theta by cos theta, that will be tan theta, like this. Okay. Now next is tan inverse. What is 1? What is 1 is here? 1 is tan pi by 4. So we can write like this, tan pi by 4 minus tan theta divided by 1 plus, now here again the same thing, nothing is there, so we can take 1 here. So that will be 1 into tan theta, and 1 is what? 1 is tan pi by 4 into tan theta, like this. So this is a formula, tan A minus tan B divided by 1 plus tan A tan B. So what is the formula? Tan a minus b, that is tan pi by 4 minus theta. So tan inverse and tan is there, so that will be only pi by 4 minus theta. So here it is coming pi by 4 minus theta, and here pi by 4 minus theta. So what will be theta? Now you can see we have taken x equals to cos 2 theta here. X equals to what? Cos 2 theta. So from here we have to find the value of theta. Now if cos goes there, it will be cos inverse of x equals to 2 theta. So from here theta will be half of cos inverse of x. So you can see theta is what? Half of cos inverse of x. Now so it will be half of cos inverse of x. If I let this one as y, okay, let this one as y, so what will be the differentiation? That means with respect to x, I am differentiating both sides, that will be dy dx. Now here we can see pi by 4. Now what is the derivative of pi by 4? That is 0 minus half into cos inverse x. What is the differentiation? Minus 1 by root over of 1 minus x square. Now it will be 1 by 2 root over of 1 minus x square, like this. So that will be the answer. Okay, so this is the substitution. First we have to think what is given. So here again, if I recap this one, we can see there is 1 plus x, 1 minus x. If there is 1 plus x, 1 minus x, take x equals to cos 2 theta and use the formula. After the simplifying, we have to find the differentiation, like this. Okay, so that will be the answer. Done. Now go to next one, question number 3. So next one will be question number 3. Now how to solve this one? Sine inverse, suppose it is given cos inverse, suppose it is given y equals to cos inverse, okay, 3x plus root over of 4 into root over of 1 minus x square by 5. Okay, this type of thing is given. You have to find the differentiation of that one, derivative of that one. Okay, so y equals to cos inverse 3x plus 4 into root under of 1 minus x square by 5. Now again we have to use a substitution. What substitution we need to take here? So we can see here now 1 minus x square. So I have given the formula. So here I have given the formula. Whenever there is 1 minus x square, take x as sine or cos. Okay, so here I am taking x equals to sine theta. So that will be x equals to, suppose take sine theta or cos theta. Suppose I am taking x equals to cos theta. Okay, so let x equals to cos theta. If I take x equals to cos theta, that will become like this: y equals to cos inverse, okay, 3 cos theta plus 4 into root over of 1 minus cos square theta divided by, that will be 5. Done. So that will be cos inverse. Again, if I separate this one, that will be 3 by 5 cos theta plus 4 by 5, and that will be root over of 1 minus cos square theta, that means sine theta, sine square theta, and root is, that is sine theta. So it will look like this. Okay, now very important one: 3 by 5 cos theta plus 4 by 5 sine theta. Now what is next? Now we can see there is a cos inverse. So somehow you have to there will be a cos, you have to make it into cos. The whole thing we have to make it to cos. So how to make it? So look at here. First, what is the term here? 3 by 5. So 3 by 5, I will take anything as cos or sine. Okay, so I am taking, we have to let 3 by 5, suppose I am letting 3 by 5 equals to cos alpha. Okay, one can let it as sine alpha also. So if cos alpha is 3 by 5, what will be sine alpha? What will be sine alpha? If I look at the triangle, so I know what is cos. Suppose this is alpha and this is a right angle. So it cos is what? Base and hypotenuse. If I solve this one by Pythagoras theorem, it will come like this. It will come 4. It will come like this and it will be 4. Okay, so this is 4. Now you can see what is sine here? Perpendicular by hypotenuse, that means 4 by 5. So from here you can say sine alpha is what? 4 by 5. So here 3 by 5 we have taken cos alpha, that means that will become what? Sine alpha. So that is y equals to, that will be cos inverse. We have taken 3 by 5 as a cos alpha, so that will be cos alpha into that is cos, we have taken cos theta, yes, cos theta, plus now next one is sin alpha, and that is sin theta. So that one will be cos inverse. So look, again cos a cos b plus sin a sin b, that means cos a minus b, like this. So here, from here we can say that will be cos inverse, and cos is there, that will be alpha minus theta. Now what is alpha? Now from here, if you simplify that one, look, cos alpha or alpha is what? Suppose from here, if I say alpha, what is alpha? Cos inverse 3 by 5. Whatever be, look, this is a constant. Nah? If I found from here also, if I say alpha, alpha is sin inverse 4 by 5. This is a constant. Okay, so I'm just writing here cos inverse 3 by 5 minus, what is theta here? Now again, from here, x equals to cos theta, that means theta will be cos inverse of x. So that will be cos inverse of x. So this is my y. Now we have to find the differentiation, that means we have to find dy dx. Now if I find dy dx from here, we can see here, so what is the first here? Cos inverse 3 by 5. Now this is a constant. So what is the derivative of constant? The derivative of constant is 0 minus, now cos inverse x, the derivative will be minus 1 by root over of 1 minus x square. So that will be 1 by root over of 1 minus x square, like this. Okay, so that is a way to solve this type of problem. So using the substitution we can solve it. Okay, so this is question number 3. Next, again I'm giving a question. Okay, question number 4. I'll give the hint here. Question number 4, suppose there is a question, it is given tan inverse x by root under of a square minus x square. Okay, suppose this is given. Okay, I think we have solved this one. Yes, we have solved this one, I think. Solve. Okay, this one has been done. So next one will be question number 4, will be not this. So question number 4 you can take like this, tan inverse, okay, tan inverse root under of, it is given a minus x, a plus x. Okay, this one. So here again we can see, whenever this type of function will come, now minus x plus x, okay, and root under of this, again we have to take x equals to what? Cos 2 theta. And since there is a, so we have to take a cos 2 theta. Okay, now solve this one. If I solve this one, now look at this, this is, we have taken x equals to cos 2 theta. So what will happen then? Tan inverse will become like this. Okay, tan inverse root under of a minus x is what? A cos 2 theta. And here also you can see a plus a cos 2 theta, like this. So in the numerator you can see root under of, if I take a, that will be 1 minus cos 2 theta, and here it is a into 1 plus cos 2 theta. Okay, so a and a, that is cancel out, so that will be tan inverse of root under of 1 minus cos 2 theta means 2 sin square theta, and 1 plus cos 2 theta means 2 cos square theta. Okay, so 2 and 2 cancel out. Now we can see this is sin square by cos square, that means tan square, and root is there, so that will be only tan theta. So tan inverse of tan theta. Okay, so now from here we can write it theta. And what is theta here? That theta is here. Now from here again we can find the theta. So we have taken x equals to, what we have taken is x equals to a cos 2 theta. Same thing, a cos 2 theta. If a will come in, that will be x by a, that is cos 2 theta. Okay, so that will be cos inverse x by a, and that will be and half will go there, so half, that is theta. So theta will be half cos inverse x by a. We'll solve it, we'll get the result from here. Now if I differentiate this one, that is dy dx half cos inverse x, and we'll x by a, and we'll get the result. Okay, like this. Okay, so whenever this type of thing will come, we'll solve like this. And next one is very important one, question number 5. Now question number 5, so this one, question number 5, this is tan inverse, very important, tan inverse of x to the power 1 by 3 plus a to the power 1 by 3 divided by 1 minus x to the power 1 by 3 into a to the power 1 by 3. So this is given. Okay, so x to the power 1 by 3 plus a to the power 1 by 3 divided by 1 minus x to the power 1 by 3 into a to the power 1 by 3. So here we can see this is a formula type. What is the formula? Look, this is tan x, like tan y, 1 minus tan x, tan y. It look like that. Okay, so I am letting what, x to the power 1 by 3 as any I'm letting at this as tan theta. Okay, tan theta, and a to the power 1 by 3 equals to tan some constant, because a is here constant, so I am taking at tan alpha. So what will happen then? That will become tan inverse, that will become tan theta plus tan alpha divided by 1 minus, now x to the power 1 by 3 is what, tan theta, that will be tan theta into a to the power 1 by 3. What is a to the power 1 by 3? That is tan alpha. Now what will happen here? That will become tan inverse, look, tan a plus tan b, 1 minus tan a tan b, so that will become tan a plus b, like this. So from here we can write theta plus alpha. Now theta, what is theta here? Tan inverse, that is tan inverse x to the power 1 by 3 plus, what is alpha here? Tan inverse a to the power 1 by 3, like this. Now we can solve from here. So this is the simplest form of that one. So from here we can write, from, if it is y equals to, if you let this as y, it is what, it will be tan inverse x to the power 1 by 3 minus tan inverse of a to the power 1 by 3, like this. It came like this, na? Yes. Sorry, plus, this is a plus. Now we have to find the derivative. That means dy dx, what will be the result? Tan inverse, what is the derivative of tan inverse? 1 by 1 plus x square. Okay, 1 by 1 plus x square into derivative of this one, that is x to the power n formula. So that is n x to the power n minus 1, and this is a constant because a is a constant, so derivative of constant, that will be a 0. So it will be 1 by 3 into x to the power, that will be minus 2 by 3, and it will be 1 plus x to the power 2 by 3. So if I write properly, that will be 1 by 3 x to the power 2 by 3 into 1 plus x to the power 2 by 3, like this. So that will be the answer. Okay, so this is the way to solve this type of substitution. Whenever this type of substitution came, this type of problem came, you have to take x equals to this. So depending, you always have to remember this one, these things you have to remember for the substitution, when what to take. Okay, so this thing you have to remember, 1 plus x square, take x equals to this one. Okay, so that means whenever there will be a square plus x square, you have to take x equals to what, a, since there is a na, so you have to take x equals to a tan theta, like this. Okay, suppose this there is x square minus a square, so same formula, x square minus 1 is what, x equals to sec theta or cosec theta. So here also same thing, x equals to cosec theta, you have to take cosec or sec, since there is a, so take it as a cosec theta, like this you have to take. So this is the way to solve this type of problem. In the next class we will solve several problems of derivative. Okay, thank you for today.